Here we are down at the gate, heading out to the sea. Get a bit of exploratory sample using our new thermometers on the temperature of the sea and the air today. Follow me. It's good to have a bucket, and I've also got a 2-litre ice cream container. This means when we get out here, we don't have to leave the thermometers here and lose them or drop them down or something like that. We actually use the 2-litre container to scoop water into our bucket. It's the seawater, a couple of scoops, and then we can just leave our thermometers here, leave the bucket here for a while until the thermometers take on the temperature of the seawater here. It's been a pretty warm day here. The air temperature's been up reasonably high, you know, on our humbod scale, around in the 60s. So let's see what the temperature is here, and then tomorrow morning, when it's a bit cooler, we'll do it again and make the comparison. Well, we've got a nice sunny day ahead of us, and we can set this experiment up with the help of Dudley the science duck here, and of course Mocha the science dog. What you're going to need is a few containers of different sizes. Now, we're going to use our thermometers, and we're going to get a measure of the air temperature here at the moment. The sun's going to come round, and we're going to see what effect the volume of water, the mass of water, has on its rate of change of temperature and its retention of that heat, that energy over time. Yeah, I mean, this is going to relate exactly back to that ocean over there. If we can get an idea of this and get a measure of this, we can understand how the ocean is a large energy sink, a large heat sink, and how it actually dampens down fluctuations in temperature at the coast during variations between winter and summer. We have to run, time is important, we have to run it such that each thermometer has enough time to stabilise. Now, our thermometers are all humbod thermometers. We're using the humbod scale, but there's little individual differences between their precision and accuracy. I mean, that's the same with any thermometer you use, even if it was a centigrade thermometer. So we just want to be a little precise about which thermometer is measuring which. Possibly it's better for us if we use 2 or 3 instruments here and just take an average. At the moment, we've got these here just reaching, having time, so we'll leave them for a little bit of time, and then we'll come back and we'll see what the air temperature is here, then we'll measure this temperature here. All our thermometers here, Kelvin, Carl and Karina, Kevin, Carl and Karina, hey, it's our loud boys, are reading the same. So on the humbod scale, the air temperature here at the moment is reading about 37 there, 37, 38 there. Okay, leave that. And again, 38. So we've got about a 32 38s and a 37. We're now going to put them into the little 1-litre container, and we'll get a measure of what the temperature is in our 1-litre water and let that stabilise. We've got to wait long enough to stabilise. Now, these 2 little alcohol thermometers have settled down. I've checked them for a wee while now, and we've got this one here on the humbod scale reading about 44, and this one here reading 45. So your old notebook, trusty notebook, make sure you got one of those, and we're going to start taking down some data. This is time 0, so this is the temperature of the water straight out of the tap, straight out of the storage tank. We've got rainwater, yours will be straight out of the tap, and our readings are 44, 45. Now, with the water thermometer, it's a 250ml, not 50ml, and so it takes a lot longer for the equilibrium, and it's not really up there yet. It's reading approximately 38 at the moment, It's a very slow one to respond. So we're just going to leave them in there and let it take on. We know they're all going to be the same. We got them from the same tap at the same time. That's fine. We've got to think about other variables that might affect the change in temperature besides the mass and volume. And so the amount of time they have in the sunlight and the amount of sunlight they have has to be the same. Otherwise, that would vary. The amount of time has to be the same. There may be other issues, but obviously we've got to keep Dudley away now. We don't want Dudley drinking anything or splashing it around and all mocha, so just got to keep them away for a while. Okay, there's our experiment set up. It's been a really sunny day and it's warmed up. Got our notebook. I made a wee frame so that we can put the thermometers into the big bin and the little bin. I've just had Kevin and Karina measuring this temperature, and I've had Carl and Kahu measuring these. And now I'm just going to check how we're going with these three. It's good to get a measurement of three at once. So in the 10 litres here, I've got a 55, it looks like. I've got a 54. Okay, I'm just going to get a measure of air temperature now. We need to just keep comparing it. You've got to think it's going to probably take half an hour for this little thermometer to stabilise, so it's sort of either side of the 2 o'clock, but we'll just put those back in there. We need to dry it, make sure, because if you leave moisture on the outside, that evaporation of the moisture tends to result in a chilling effect, because as the moisture evaporates, as the water evaporates, energy goes into moving those molecules, changing them into the gaseous state, and that takes the heat out of the instrument. So we'll just get a measure of the air temperature here. We'll leave that for a wee while.